Alright, so in this video we're going to talk about section 8.4 from your textbook, which really covers two main concepts. We're going to review the process of factoring, and then we're going to also talk about using factoring to be able to solve quadratic equations. One of the main uses of factoring is solving quadratic equations. And the first thing I just want to remind you of is that when I'm talking about factoring, factoring is just a process that is the opposite of multiplication. Factoring is the opposite of multiplication. There's many different types of factoring methods. There's factoring out the greatest common factor. There's factoring by grouping, factoring trinomials. There's lots of different ways to factor. We're going to kind of touch on each of those in this section as we take a review, or as we review the process of factoring. So just kind of to get to the point here that factoring is the process is the opposite of multiplication. What I mean by that is if I multiply 2 times 3, that's equal to 6. So if I go this way, this is what we call multiplying. However, if I go the opposite way, if I say that 6 breaks down into the product of 2 times 3, that's what we call factoring. And the first type of factoring that we talk about in algebra is factoring out the greatest common factor, or the GCF. And so if I take a look at this first example, we could write down real quick what is the greatest common factor. And if we look at the numbers, we have three terms here. We have one term, two terms, three terms. The largest number, or the greatest number that goes into 4, 12, and 16 would be the number 4. And then if we look at the x's, there's 2x's, 2x's, and 1x. There's only 1x that'll go into all three terms. So we have to take basically the lowest power of x. We have 2, 2, and 1x. We can only include 1x. Likewise, for the y's, we have 2 y's, we have 1 y, and we have 2 y's. My greatest common factor can only include 1 y. And so if I factor out the greatest common factor, what this looks like, and this will hopefully look familiar to you, is we pull a 4xy out in front. And then we put some parentheses here, and we want to ask ourselves, okay, what would I multiply the 4xy, our greatest common factor, by to get this first term, the 4x squared y squared? We already have a 4, so we're good there. But I would need to multiply x times x to get x squared. And I would need to multiply y times y to get y squared. And so if we take 4xy times xy, we get 4x squared y squared. Likewise, if I move on to the second term, well, it's a minus because the second term is negative. We would have to multiply 4 times 3 to get 12. We would have to multiply x times x to get x squared. And then we only have 1 y, so we're good there. If I move to the third term, I would have to multiply 4 times 4 to get 16. X, we already have 1x, but y times y gives us y squared. And then we'll go ahead and close these parentheses off. Now remember what I said. I said that factoring is the opposite of multiplication. So look what we did. We took this quantity, 4x squared y squared minus 12x squared y plus 16xy squared, and rewrote it as a product. We wrote it as the product of 4xy times this stuff here in parentheses. And if you're not sure that you did it right, one thing as a check that we can always do is we can go ahead and distribute out here and check to make sure that we get back what we started with. So if I do that, 4xy times xy is 4x squared y squared. 4xy times negative 3x is negative 12 x squared y. And then lastly, 4xy times 4y squared is a positive 16x y squared. So we're good. Hopefully that looks familiar. Let's go ahead and talk about the next example. This one, our greatest common factor, well, if I look at 9 and 6, 3 go into both of those, and then we have 2 W's and 1 W, so we can pull out 1 W. And then a lot of times we don't like to see negatives in the first term necessarily, or we don't have to do this, but we could, if we wanted, we could pull out a negative as well, since the first term is negative. And let's see what would happen if we did that. So if our GCF is negative 3W, then I would have to multiply 3 times 3 and W times W to get W squared. And then for the second term, to get a 6, I would have to multiply negative 3 times a negative 2 to get a positive 6. And I already have a W, so I'm good. So for the second problem, here is our factoring, the greatest common factor. Now the last problem, example C here under this subsection, we're going to look at, it's the same idea. We're going to factor out the greatest common factor, but this time the greatest common factor is this y plus 2 binomial. It's a little bit bigger. I can still pull it out though. So when I factor out the y plus 2, you have to ask yourself, okay, y plus 2, I have that. I have a leftover 6x in the first term. And then in the second term, I have a leftover, if I factor out the y plus 2, I have a leftover negative 3. And so again, we rewrote our quantity as a product, a binomial y plus 2 times a binomial 6x minus 3. So this example will kind of prepare us for our next subsection, and that is factoring by grouping. So if I move to section number 2 here, factoring by grouping, you can see that we have a polynomial here with 1, 2, 3, 4 terms. Now when we have 4 terms, that is what we want, that is when we want to do factoring by grouping. So this is good when we have 4 terms. And what we do is exactly what the name suggests we do. We're gonna go ahead and put this polynomial into 2 groups, a first group and a second group. And sometimes you might have to switch them around, but not always. If we go ahead and put it in these 2 groups and we pull out our GCF here, and let me actually just kind of go ahead and write this for the first one. The GCF for this first one is, if you're looking at it, I hope everybody agrees that it's going to be y. And then there is no GCF here. I mean, if we wanted to say there was a GCF, I suppose we could say the greatest thing that goes into both 2x and 3 would be 1. And so the next part of factoring by grouping is we go ahead and we pull the GCF out of our first group. So in this case, if we pull a y out, if we factor it out, what's left is 2x plus 3. And the 2x plus 3 should look familiar because that is our second group. And so, again, if I pull the GCF out, which in this case is 1, what's left is 2x plus 3. And now this problem looks a whole lot like the last example we looked at where our GCF was this y plus 2. Here we're going to go ahead and factor out the GCF again, and in this case the GCF is the 2x plus 3. We can go ahead and pull that out. And so if we pull that out front, or factor it out front, what we have left is the y and the plus 1. So this is how we factor by grouping. Hopefully that looks familiar. If we look at a second one here, we go ahead and look at our first group. The greatest common factor there is 3 and 12. 3 goes into both 3 and 12. And then we have 3 x's and 2 x's, so we can only include 2 x's. And if I wanted to multiply 3 by something to get 3, I don't really need anything. I just need a 1 there. But x squared needs to be multiplied by x to get x cubed. And then for the 12, we need to multiply 3 times a positive 4, and then we already have x squared. So for the first group, we have 3x squared times the quantity x plus 4. Now in the second group, the number that goes, or the greatest common factor that goes into 5x and 20, I would say is the number 5. And if we choose 5 here at first, we're going to see though that this creates a problem, because 5 times negative x gives us negative 5x, and 5 times negative 4 gives us negative 20. The problem here is that these two parts in parentheses do not match up. This is a x plus 4 and this is a minus x minus 4. And so hopefully you can see that what we need to do here to be able to fix this problem is, instead of having a positive x get factored out, what if we factor out a negative, instead of factoring out a positive 5, let's factor out a negative 5. So negative 5 times x makes negative 5x. And then negative 5 times a positive 4 gives a negative 20. Okay, so now we have x plus 4 in both places, and when we have x plus 4 in both places, that allows us to complete the factoring by grouping process of pulling out the x plus 4, leaving us with a 3x squared in the first term and a negative 5 in the second term. So this 4-term polynomial has now been factored. Factoring by grouping, again, a little note here, factoring by grouping should be tried on polynomials that have 4 terms. So this brings us to factoring trinomials, and factoring trinomials is the kind of factoring we're probably going to see most often. One thing that you really need to make note of is whenever we're factoring trinomials, we should always ask ourselves, can we factor out a greatest common factor first? That was the first skill we talked about in this section. A lot of times if there is a greatest common factor we can pull out, it's going to make our life a whole lot easier. So if we look at this first example, x squared plus 6x plus 8, there is nothing that goes into all 3 terms. We can't factor out a greatest common factor. So we then move on to looking at how does this factor. And so when factoring this, we need to remember that this type of factoring, well, any type of factoring is the opposite of multiplication. In particular, this type of factoring is the opposite of what many people like to call FOIL. And so let's kind of work through this, and then we'll go back and show you how it's the opposite of FOIL. The first thing is that FOIL, when we FOIL, we're multiplying 2 binomials, so it's like 2 terms in parentheses times 2 terms in parentheses. And it usually works out that these first 2 spots is the first part of the multiplication. So what we're going to do is we're going to ask ourselves, what times what gives us this first term, x squared? And of course that is going to be x and x. So x times x gives us x squared. And then we're going to move to the last, the L, the last term of the first one, the last term of the second one. And those two usually give us the last part here. That's the 8. So of course that's probably going to be maybe 2 and 4. Okay, 2 times 4 equals 8. But it could also be 1 and 8. 8 happens from getting 2 times 4 or 1 times 8. But what we're about to see here in a second is we need to choose these 2 factors, in this case 2 and 4, so that not only do 2 times 4 multiply to give us 8, but also add to give us 6. And of course, positive 2 and positive 4 could give us 8, or negative 2 and negative 4 could also multiply to give us 8. Let's go ahead and start here with a positive 2 and a positive 4. I am going to suggest to you that this is how we would factor this trinomial. But let's go ahead and FOIL and check to make sure that that is actually the correct factoring. So if I go ahead and FOIL it out, remember we do F first, we do the first two terms. X times X is in fact X squared. And then we have O, that's the outer, we have X times 4, which is a positive 4X. And then we have the I, the inner, 2 times X, which is a positive 2X. And then we have the last, we have 2 times 4 is 8. And you will of course see that these two middle terms here, the 4x and the 2x, those are the two terms that combine or add. 4x plus 2x combines to give us this 6x. So that's why I said we needed, when we were trying to figure out these two spots here, the 2 and the 4, we needed two numbers that multiplied to give us this 8, but also added to give us the 6x. So this is in fact the correct factoring for x squared plus 6x plus 8. Let's go ahead and look at another one here. Here again, the first part of this factoring is going to be x times x, because x times x is the only way to get x squared. Now we're looking for ways to get 20. So if I go ahead and write those over here off to the side, we have of course 1 times 20, we have 2 times 10, and then the last way to get this is 4 times 5. Now remember, we needed two things to multiply to give 20, but also add to give us 8. And the only two combinations of numbers here that can add to give us 8 are going to be the 2 and the 10. And in order to get 8, we need the 10 to be positive and the 2 to be negative. Because if I go ahead and check that FOIL, the inner product is a negative 2x. The outer product is a positive 10x. And if I add those up, negative 2x plus 10x is an 8x, which is of course what we wanted. So the correct factoring is x minus 2 times x plus 10. Now of course they're not always this easy, and in a little bit here we're going to look at some that are a little bit more difficult to factor, but for right now that's the two we're looking at. Now if I move on to this next one, remembering that we always want to ask ourselves, can we factor out a greatest common factor first? We should ask ourselves that, but since there's not an x in every term or a y in every term or even a number in every term, again that's not going to be possible. So let's go ahead and write our two sets of parentheses here. Again, we're going to ask ourselves what times what gives us x squared, and in this case we have an x and an x again. Now don't be scared of the fact that it's not just a number in the last term. We're still going to treat this the same way. What are numbers that multiply to give us 14? Well, for 14 we really only have 1 times 14 and we have 2 times 7. So more than likely, you can see the first two examples we've done, we haven't chose the 1 times the number. And most of the time it's not going to be that option. So let's go ahead and try 2 and 7 first. But 2 times 7 only gives us 14. We also have a y squared. So we also need to include here a y and a y, because 2y times 7y is 14y squared. Now, we also need to keep in mind that these two numbers need to add to give us 5. And if that's the case, we need a positive 5 and a negative 2. And checking this, then our inner product is negative 2xy, and our outer product is positive 7xy. And if we combine those, we'll see that we got the correct factoring. We got negative 2x plus 7x is 5xy. So this is our correct answer. This brings us to the fourth example, and here things get a little bit more complicated. Now, in order to get 8x squared, we can't just use x and x anymore. We might use something like 2x and 4x. It's probably not going to be 1 times 8 to get 8. It's probably going to be 2 times 4. And then the rest of it we proceed the same way. We know that to get 15 we either have 1 times 15 or 3 times 5. And we've seen more than likely this is probably going to be the 3 times 5. And so we can put these in here. We could put, for example, a 5 here, and we could put a 3 here, and because 3 times 5 is 15, and then we want to provide that same check. We want to look at this and say, okay, that one's 20x, and this one is 6x, and you can see this is a problem. We can't use 20 and 6x to get 22. So this is not the time to just go ahead and quit and give up. What we should probably do instead is switch the place of the 3 and the 5. We should make this one first spot the 3 and the second spot the 5, and then check to see if it works now. So here if we do our inner product we get a 12x, and our outer product is a 10x. And this does add up to 22x. So we found the correct factoring. Now, this is going to require some guessing and checking. You might not get the right answer the first time, and that's okay. You don't have to get the first answer the right time. You just need to know how to keep checking until you get the right answer. Now some of you are probably saying, well, I think I learned how to do this using another method when I was in school or when I was in algebra, and you're probably right, you did use some little fancy trick. In fact, there's all kinds of ways that teachers teach students how to factor. Let me remind you of maybe a couple of other ones if you want to go back to maybe a prior method that you learned. Again, our polynomial was 8x squared plus 22x plus 15. And so one method that students will learn sometime is they'll make this like diamond shaped thing, and what they're going to do is put a number here which is the product of a times c, where we have ax squared plus bx plus c. And of course here a would be 8 and b would be 15, or c would be 15. So a times c would be 8 times 15, or in our case 120. And then the bottom part of the diamond here is going to be the number b, which in our case is 22. And what we want is two numbers that multiply to give us 120 yet add to give us the 22. We want to add to get that, and we want to multiply to get that. And of course those two numbers are going to be 10 and 12. 10 times 12 is 120, and 10 plus 12 is 22. And so then what we do is we use the 10 and the 12 to help us factor. We replace this 22x with a plus 10x and a plus 12x, and then we have the 15. Of course we can do this because 10x plus 12x is 22x, and now all of a sudden we have four terms, so we can factor by grouping. In this first group we can pull out a 2x, which leaves us 4x plus 5, and in the second group we can pull out a 3, which leaves us 4x plus 5, which is great because now we have that common 4x plus 5. We can pull out the 4x plus 5, which leaves us 2x plus 3, which is exactly what we had on the other page. Another method that is sometimes used is a method I teach in my classes, and it's really doing the same thing. It's just kind of a different way of going about it. Our first column, we're going to have the a times c. I'm sorry, take that back. Our first column is just going to be a. Our second column is going to be c. And then, so two numbers that multiply to give us a might be 8. So a is 8. So two numbers that multiply to give us 8 are, say, 2 and 4. And then two numbers that multiply to give us c, and of course c was 15, might be 3 and 5. And then the rest of this, the next table we get, this third column, the next part we get by multiplying across. So we take 4 times 3 is 12, and 2 times 5 is 10. And these two numbers need to add up to give us b. b is this bottom part. And of course b was 22. And yes, of course, 12 and 10 do multiply to give us 22. So we're good there. In fact, we need a positive 12 and a positive 10, which means this needs to be a positive 3 and this needs to be a positive 5. And of course, this wasn't just 8, it was 8x squared. So here we need an x, and here we need an x, because 2x times 4x is 8x squared. And here's the two parts of our factoring. We have the 2x plus 3 right there, and we have the 4x plus 5 right there. So if you haven't seen that method before, don't worry about it. It's not important. If you haven't seen this method before, don't worry about it. It's not important. You can use either one of these methods. You can use maybe another method that you learned in your algebra class. You can use this guess and check method like we talked about in the notes already. The choice is yours. You just need to know how to factor. And sometimes you get to one that is not even factorable. And so here is one that's not factorable. We could try 4x and 2x. Of course, 10 is gotten by taking 5 times 2, right? And so here we have a 10x, and here we have an 8x. I can't get 5 with 8 and 10. So then we might try switching the 5 and the 2. If we switch the 5 and the 2, this is a 4x and this is a 20x. Again, that doesn't give us 5x. We could try making this a 1 and a 10 here. Instead of this, we could have a 1 here and a 10 here. If you could go through and exhaust all your options, and you're going to see we will not be able to find a way to factor this. And if it's not factorable, we just go ahead and say that our polynomial is prime. So let's take a look at one more example with factoring trinomials, and this is example F. And we always again want to ask ourselves, can you factor out a GCF? And in this case we actually can. We can pull out a 2, which if we pull out a 2, that leaves us x squared minus 8x minus 48. Now if we pull out a GCF, we still have to have that 2 tag along. So we'll leave it out front, but then we go ahead and factor the trinomial that remains, and of course x times x gives us x squared. Two numbers that multiply to give us 48. Well, 48, we can use 6 times 8. We can use 4 times 12, and I think 4 times 12 already we're going to see that's the number we want, because we can get negative 8 if we have a negative 12 and a positive 4. So there's our answer for factoring the last example. Now might be a good time for you to go to your self-check and look at doing the first three problems. We've talked about how to factor out a greatest common factor. We've talked about how to factor by grouping. And then we have a number of examples here. Probably you can do thus far, you could do example A and example B and example C. You want to wait here before trying D and E until we cover the next section. So you can go ahead and pause the video and then come back when you are finished. I am going to now go to the second page of the notes. Hope you had a okay time with your self-check. Second page deals with some special products. We have what's called difference of squares polynomials, perfect square polynomials, and there is a typo in here. This should be, I just noticed, should be 2ab, and this should be a 2ab, so there's a typo. And really, you could use these rules, but you can also go back to what we talked about on the first page and just use the tools that we talked about there. This first example, example A, we want to first ask ourselves, can we factor out a GCF? And we cannot. And this is one where we have a perfect square, because the first term, x squared, is a perfect square. X times x gives us x squared. And then the last term is also a perfect square, because 8 times 8 gives us 64. And of course 8 plus 8 gives us 16. So this is one of those perfect square polynomials. Of course these both need to be positive, and since they're the same, x plus 8 times x plus 8, this is going to be rewritten as x plus 8 quantity squared. If we look at example B, again we want to ask ourselves, can we pull out a greatest common factor? And in this case we can pull out a 2x squared. 2 goes into both 2 and 18, and x squared goes into x to the fourth and x squared. Now 2x squared, we need to multiply x squared by x squared to get x to the fourth, and then in the second term we need a negative 9. Now, just like the last time we pulled out a greatest common factor, we're going to bring the GCF along for the ride, but we're going to now attempt to factor what's inside the parentheses. And this is where we have a x squared minus 9. That's a difference of squares. That's another special product. That's this first guy here. That's when we have something squared minus something squared. And if we have that, it factors to the first thing plus the second times the first minus the second. So in this case, it's going to be x and x and a positive 3 and a negative 3. And the reason why this works out is because notice we're missing our bx term in the middle here. That's because our inner product is a positive 3x and our outer product is a negative 3x, which of course add up to 0x. That will always happen with a perfect, or with a difference of squares polynomial. So our answer in this one is 2x squared times x plus 3 times x minus 3. Which brings us to the next example, y squared plus 1. And this is one that students always think is factorable, but this is not a difference of squares. This is a sum of squares, which turns out is not factorable. In fact, it is never factorable. So this guy we would call prime. This is a prime polynomial. The last two examples under the special polynomial section is the sum of cubes and difference of cubes. And really, to be able to do these, you need to recognize that there are two terms, and these two terms are both something cubed. In fact, for this first one, it's going to be 2x cubed, because 2x times 2x times 2x is 8x cubed. And then the last one, the thing that's cubed, is just 3. And this is going to be the difference of cubes because we have something cubed minus something cubed. And so if we all we do is we follow the pattern here, recognizing what A is and what B is. And of course, A in this case is 2x, and B is 3. So if I go to factor it, the first thing I have is A minus B, which in this case is going to be 2x minus 3. A minus B is 2x minus 3. Then we move to the second set of parentheses. We have A squared. Well, A squared is 2x times 2x, which is 4x squared. Then we have A times B, which is 2x times 3, or a positive 6x. And then lastly, we have B squared, which is going to be 3 times 3, or 9. And that is how you factor a difference of cubes. The last example here is a sum of cubes. Again, we only have two terms, and the two terms are something cubed plus something cubed. So again, we should probably try to recognize what is it that we're cubing here in both the first term and the second term. The first term, it's going to be 2x cubed, because 2 times 2 times 2 is 8, and x cubed times x cubed times x cubed is x to the 9th. And then the second part is 5, because 5 times 5 times 5 is 125. And here we're going to follow the sum of cubes pattern, remembering that A is 2x cubed, and B equals 5. So this is going to factor to, first of all, A plus B, or since A is 2x cubed, it'll be 2x cubed plus 5. And then we have A squared, which is 2x cubed times 2x cubed. Or 4x to the 6th. And then we have minus A times B, which is 2x cubed times 5, or 10x cubed. And then finally we have B squared, which is 5 times 5, or 25. And that is how you factor a sum of cubes. So one thing I want to point out in this section is there's 3 different examples where we factor when we have two terms. We have a difference of squares, a difference of cubes, and a sum of cubes. Anytime you have two terms, it's going to be one of those 3 examples. So now that we've covered factoring, I want to move on to solving quadratic equations by factoring. So the last part here is the 5th section. We're going to now use our skills learned in factoring to solve quadratic equations. And the property that we use to help us do this is the zero factor property, and it should make a lot of sense to us conceptually if we think about it. First of all, a quadratic equation is any equation that looks like our quadratic form, ax squared plus bx plus c, and is in the form where it's equal to 0. So we got to have it equal to 0 actually to be able to use this zero factor property. It doesn't always come out, an equation's not always given to us set up equal to 0, but we can easily make everything on one side set equal to 0. Now here's the zero factor property. It says this, it says that if we have a product, A times B, and those two things multiplied by each other are equal to 0, then either the first thing has to be equal to 0, A has to be 0, or B has to be 0. In other words, if I have something, say a number 2, and I multiply it by something, the only thing that I can multiply 2 by to get 0 is 0. Likewise, if I take and multiply in the opposite order, the only thing that I can multiply 2 by is 0 to get 0. So let's consider how we can use this to help us solve quadratic equations. If I have a quadratic equation, x squared minus 5x minus 6 equals 0, think for a second about how we can use this property to help us solve the equation. And the answer is that we need to make the left-hand side, this stuff, we need to make it look like something times something. Well, how do we do that? That is called factoring. That's the process of turning some quantity into a product. And so here we have, of course, x times x, and we have a minus 6 and a positive 1, because negative 6 times 1 multiplies to give negative 6 and adds to give negative 5. So now we have this first part of the zero factor property established. We have something times something equals 0, something times something equals 0. Then the second part says then the first part equals 0 or the second equals 0. In other words, x minus 6 equals 0, that's the first part, or x plus 1 equals 0, that's the second part. And of course we can solve both of these separately. Here we get x equals 6, and here if we subtract 1 we get x equals negative 1. So we get two answers. We get x equals negative 1, x equals positive 6. One important note I just want to bring up here is that in order to use this zero factor property, we have to collect all terms on one side of the equation. We have to have it look like this. I already mentioned that before, I just want to mention it once more. Now, if we take a look at a couple of other examples like this, we have, for example, this guy, which factors very easily into x and a minus 10 and a minus 2, because negative 10 times negative 2 is positive 20. And we get a negative 10x and a negative 2x, which adds up to negative 12x. So then we have x minus 10 equals 0, or x minus 2 equals 0, which gives us x equals 10, or x equals 2. We get two answers. We have another one. What's wrong with example B here? What do we need to do first? Well, we need to get it like the one in example A, where we have it set equal to 0. Well, to do that, we need to add 2x to both sides. We need to get that negative 2x to the left side, which makes it a 5x squared and a positive 2x equals 0. And again, we want to factor. Well, remember we looked at when we had two terms that was the type that were sums of cubes, or difference of cubes, or difference of squares. Here we actually don't have any of those, but remember the thing we need to do first whenever we're trying to factor is to factor out a greatest common factor, which we do have here. It's x. If we do that, we're left with 5x plus 2, which is good because this is again something times something, which we can apply the zero factor property and gives us the first something equals 0, or the second something equals 0. Here we're good, x equals 0. The other one is going to have 5x. If we move the 2 to the other side, it becomes a negative 2. And we can divide by 5. We get x equals negative 2 fifths. So my answer is x equals negative 2 fifths and 0. Now the last one, sometimes students want to go right off the bat and say, oh, well, x equals 0 and 13 minus x equals 0. The problem with that, the reason why we can't do that, though, is because it's not equal to 0. We can't just go ahead and apply the zero factor property, because that requires us to have something times something equals 0, which we don't have here. So think about maybe what we might do here to yourself for a sec. If we're going to get everything on one side equals 0, one of the first things we need to do is distribute. So we're going to distribute here, which gives us 13x minus x squared equals 40. And one of the things about factoring, if we're going to factor, it's nice to have the x squared always be the positive term. Every problem we've looked at in this class factoring, the x squared is always positive. And the way it is right now, this x squared is negative. So I'm thinking we should move everything over to the right-hand side, which in this case we're going to have 0. This negative x squared on the left side becomes a positive x squared on the right side. This positive 13x on the left becomes a negative 13x on the right. And then this positive 40 was already over there, so it'll stay a positive 40. And now we can go ahead and factor. X times x is x squared. Stuff that multiplies to give us 40, well, that's 1 times 40. Probably not likely to use. We have 4 times 10. That doesn't add to give 13. How about 5 times 8? 5 times 8 does give us 13. And since it's a negative 13, we need both of these to be negative. But now we can apply the zero factor property. X minus 8 equals 0, or x minus 5 equals 0, which means x equals 8, or x equals 5. And that brings us to the end of this section. Thank you. Just a reminder, make sure you finish the self-check. We never mentioned this, but you should now be able to do D, E, and also solve the quadratic equation in problem 4. Thank you.